Hello and welcome to Your Favourite Teacher. I am Miss Smith and today we are going to be talking about tectonic plates. So, it's really important before we understand tectonic plates that we get to grips with the Earth's structure and how it is formed. The centre of the Earth is made up of two parts, the inner core and the outer core. The inner core is the hottest part of the Earth. It is solid and made up of iron and nickel with temperatures of up to 5,500 degrees Celsius. The outer core is the layer that surrounds the inner core. It is liquid and also composed of iron and nickel. Around the core we then find the mantle. This is made up of semi-molten rock called magma, which moves very slowly. The mantle makes up approximately 84% of Earth's volume and is the thickest layer. The final layer is the outer layer, which is called the crust. This is a thin layer of solid rock upon which we live. Right, now we've got an understanding of the Earth's structure, we can move on to looking at tectonic plates. The crust is divided into slabs called tectonic plates, which float on the mantle. The plates are made up of two types of crust, continental and oceanic. Continental crust is the thicker of the two, between 30 and 50 kilometres, and is less dense. Oceanic crust is thinner, between 5 and 10 kilometres, and is more dense. The places where plates meet are known as plate margins or plate boundaries. So, inside the mantle, heat is rising and falling, creating something known as convection currents, which are generated by radioactive decay in the core. These currents cause the plates to move. Where these convection currents diverge near the Earth's crust, plates move apart, and where convection currents converge, plates move towards each other. This movement of the plates and the activity inside the Earth is what we call the theory of plate tectonics. Okay, so now that we've established that there are different types of tectonic plates and that these plates move in varying directions, we can look at the three different types of plate margin. Firstly, there are destructive margins. These margins occur when there are two plates moving towards each other. An example of this is along the west coast of South America. Where an oceanic plate meets a continental plate, the denser, heavier oceanic plate is forced down into the mantle and destroyed. This is known as subduction. This often creates volcanoes and ocean trenches, which are very deep sections of the ocean floor where the oceanic plate goes down. When the plate sinks into the mantle, it melts to form magma. The pressure of this magma builds up beneath the Earth's surface, causing it to escape through weaknesses in the rock and rises up through a composite volcano. The volcanic eruptions are often violent, with lots of steam and gas and ash. Where two continental plates meet, the plates collide as neither can sink, and therefore the land buckles upwards to form fold mountains. This is known as a collision margin. Earthquakes can also occur at these margins. Secondly, there are constructive margins. These margins occur when there are two plates moving away from each other. An example of this is the Mid-Atlantic Ridge. When this happens, the magma from the mantle rises up to make or construct new land in the form of a shield volcano. The movement of the plates over the mantle can also cause earthquakes. Finally, there are conservative margins. These margins occur when plates move past each other or are side by side, moving at different speeds. An example of this can be found along the west coast of the USA. At these conservative margins, crust isn't created or destroyed. Rather, as the plates move, friction occurs and plates become stuck. Due to this, pressure builds up because the plates are still trying to move. Eventually, when the pressure is released, this causes an earthquake. These earthquakes can be very destructive as they occur close to the Earth's surface. At these margins, volcanoes do not occur. So, to summarise, the Earth is made up of the inner core, the outer core, the mantle, and then the crust. This crust, which is either oceanic or continental, is divided into slabs called tectonic plates. These plates move in different directions due to convection currents in the Earth's mantle. Because of this, we have 3 different types of plate margins where different plates meet. Destructive margins, where 2 plates move towards each other. Constructive margins, where 2 plates move away from each other. And conservative margins, where 2 plates move sideways past each other. At these places of high tension and energy, volcanoes and earthquakes can occur. I am Miss Smith, and we have been revising tectonic plates. Thanks for watching.